You can just search on the GitHub. So it kind of few character here if you want, or just using a QR code. So I guess it's good for the begin. So in this tutorial, I first want to introduce the concept of the OaaS. So, but before that, I want to present you our vision and motivation, like why we need a OaaS. And then I want to update the current state of the art that like fast or function as a service and why it have a problem and why we introduce a new abstraction to the cloud. And then we go to the OaaS and talk about the goal, why we decide to OaaS, and then the concept of it. Then we describe like what the application development gonna look like with the OaaS. Are you hear me like clear and sound? Okay. And then we will go to the Upalaga. That is my prototyping of a OaaS. I will just discuss the design decision and the goal, followed by the architecture, and then I have some evaluation that because I have a public paper to the IEEE cloud before, and then I will show what is the development tool that available to use, and then I will show the tutorial of Upalaga. Okay, first, let's talk about what is the serverless paradigm. So as we know that part of few decades, we see the trend in the cloud that trying to go towards to higher the abstraction. So at the beginning, we have something like in-house server that basically we just buy the hardware and then manage everything basically. And then we have an infrastructure as a service. Basically the cloud that we just renting the VM and then have them manage the hardware level, but we just use the operating system. And then they give us the more higher abstraction that called platform as a service. So the cloud provider give us the platform that we can install and the most of the kind of popular platform for the application, and then we just shipping our code as a platform there. And then lastly, we have a higher abstraction that called as a serverless cloud. The idea is that the developer don't need to worry about the internal detail anymore. So they want us to just writing the code, a code that I want to say is a business logic. So that means the developer don't need to worry about like how to scaling or how to optimization, something like that. That is the idea of the serverless. So, and in the serverless, we have one paradigm that we call as a fast or function as a service. So the idea is that we have the event and we write some kind of like trigger to triggering the function and just doing the thing that it's supposed to do. The good thing about the function as a service, there are a lot of things. The first one is like higher abstraction, but the main thing that make it people interesting on it is that the model, the payment model is it called pay as you go. So that means you don't need to pay to reserve for the resource anymore. You pay for the your actual usage of it. So why it can happen? Because they have something called auto scaling that when you have a load, it just scaling up to the exact amount of the load that the user generate to your system. But when there are no load, it just not have any resource running for reserving it. So why we need higher abstraction? So first, we want to democratize the application development. So like imagine that if we have a low abstraction that we need to have a higher knowledge to have a like one programmer. So that means we can have like only one. But if we have a higher abstraction, we might need to have a more manpower. And then we want to reduce the human error because when we have a higher abstraction, we can automating something that like usually like human doing it. And then we can reduce the time to market. So that means usually if we can reduce the time to market, we can reduce the cost of the missing opportunity. So when we think about the ideal of the cloud domain application, what should be as how it look like. So that means when we have a code, we want to have some kind of like magic to make it become an application like behind the scene. But the thing is, it's not that simple. We have something that we need to do. The first like infrastructure and the resource that we need to manage. And then because we have a serverless system, yeah, it's sold by now. But the serverless system that we have now, it not cover the state or like data management. And it not completely cover the cost and performance optimization. Even though I say that we have a new model that I pay as you go, but I will go to that. What is the problem? And then about the scaling, even though it can be scaled on higher abstraction, but if you want to like fine tuning it, it still have some certain problem. So let's talk about one by one. What is the shortage of the fast? So in here, we have first the developer need to manage application. So that means it's not completely the serverless at this as we want. We want to have like something that like have a just coding and shipping it to become an application. But now we have a thing more thing that we need to do, that is the data. So to manage the data, we usually need to go to the cloud portal and then create a new database service. And then we have a lack of the encapsulation. The function and data are separate. So that means we are have a completely separate entity that manage on their own thing. Like we have a file system that manage the function, and then we have a database system that just manage the data. And the lacking of the built-in asset control. So the problem is that the everything is become a function and they have a asset everything, so they don't have a semantic that kind of embedding the asset level of control. So that means the application developer need to do it by themselves. And it also lacking the built-in data flow semantic. So normally in the file system, they have, if we need to have a chaining between the multiple function, we need to employ another workflow orchestrator. We, like for example, in the AWS, we have a AWS step function, but it have a kind of still separate. It not completely integrate with the file system yet. Yeah, and then when it become a problem on the performance optimization, I will say the first is the function and the data is separate. So that means we missing the opportunity to have a cross domain optimization. So like for example, like if we know that the function or like our code want to access the data a lot, we might want to make them stay close together to achieve a higher data locality. That means we can have less latency and reduce the network cost. But because they are separate, so it kind of limit the option that you can do that. And then it kind of counterproductive between the cloud and developer coordination. So the thing is, if we think about the optimization in the developer perspective, we want to optimize for the higher application performance or like lower the latency. So that means we usually want to have a more resource for your application to running it. But for the cloud perspective, like cloud provider perspective, they want to maximize the resource utilization. So that means they need to kind of put a bunch of workload into the same machine, like same hardware level machine. That means we not really get the resource that we exactly want unless we over provisioning it. So, and you can see now the goal of the organization on both sides counterproductive. And the optimization usually come in the primitive form, like number of CPU, something that like if we need to do some kind of optimization, we need to do some kind of like trial and error. Like we set up some parameter and then we do the load testing and then we get the result back. And then if the result like latency not satisfying or like the throughput not satisfying, we need to redo it again. So what I'm missing that they did not have like non-functional requirement as the awareness of it. So what kind of non-functional requirement that I talking about? So let's say that as a requirement, we might have a low quality, like we want to have everything stay on the same host or the zone or the same lab. But so at the throughput, we might want to like specific amount of the throughput that the application want. Like for example, like they might want like 1,000 requests per second, and then we have a availability that they might want like 99.95% higher of the uptime. So for the constraint, it's more like a configuration. I just want to go really quick. Like for example, like function deployment, we might can able to select what type of the platform that we want to go, or we might want to say that if we want to persist the data or not, something like that. And because of that, we want to introduce a new paradigm that we call as the object as service. Sorry, not working. Okay. So in the object as service, we want to switch between few things. First, you can see that there are state management in the fast or on the top of figure. Can see that the developer need to write the state management by themselves, but in the OaaS or object as service, we want to make it become a part of the platform and highly integrate with the data storage. So because of that, the function can just accessing it. So it reduce the workload for the developer. And second, we want to integrate the data flow management with the workflow orchestrator. So that means we want to have a workflow act at the function. I will go to that point later. And then we want to incorporate the non-functional requirement as the key to dive in the optimization. So normally for the file system that I say that we need to have like a lot of like manual and repetitive refinement, but in the OaaS, we want the developer to just give us the high level number, like to put or the requirement that they want, and then we want to have a system that somehow figured out what is the best low level optimization parameter for that optimize for this requirement. So first, for the optimizing the requirement, that it's not just a high level, but we see that everything in the same platform now, we unlock the cross domain optimization that cannot be possible in the fast system because in the fast everything is managed in the separate abstraction. And we want to have a high level and app-friendly and non-requirement that I already talking about. And now we have something that drive the optimization. So the cloud and the application don't need to be in the counterproductive anymore because we have the same goal. Cloud can do any way that they want if they still can meet the requirement. And now we can see that because the requirement is now at a high level, so that means it abstract from the platform and the environment. Like imagine like in file system, if we switch from like one cloud to another cloud, we might say that there might have like different environment. The location between like database and the serverless system might be not in the same distance, something like that. So that means if you switching between the cloud, you might need to do the refinement again. But as the OS, because everything become a high level and it automate by it, we want to make it become a portable. So that's the goal. Let me recap everything. So the goal for the OS, first we want to abstract the data, workflow, and resource management, and then the non-functional requirement. And then we want to visualize it, encapsulate them, data and function become an object. So that also they unlock the core domain optimization, and then use the non-functional requirement to guide the optimization. So one thing that I want to note for that there are some time that people misunderstanding. We design OS not just as a replacement for the fast, but we want to become the complementing the lacking of it. So there are some use cases that the fast system still great and do well. That is like some kind of stateless, completely stateless application, or some application that they don't want to have additional abstraction. Like as you know that when you develop some kind of application, sometimes you don't want to have like too much abstraction because you want to control everything. It's kind of specific case, but that kind of use case that it not suit well for the OS. But other than that, I believe that OS should be doing well. Here, for the OS, now I'm talking a lot about the goal, but what actually how it gonna look like. So, like imagine that we have a developer that writing the code. We call this as a function, and then function gonna build the packaging in some form of a container image. And developer need to write something kind of similar to the OP that we have a class to writing the object. Now we have a class definition. And when we combine the class definition and the container image of the function, we deploy in form of the class runtime. And class runtime realizing the object that's going to be used by the user or the author system. And we can see that where the OS work is providing the class definition abstraction, and then make the deployment, handle the class runtime process, and make the manage how the object gonna work in this platform. So let's focus on the first part, what the class definition gonna look like. So the class definition, we believe that it should comprise of the multiple function at the state. But now I want to focus on the function. So in the function, we categorize them to become a three types. First, we call it as a built-in function. So we believe that when we deploy, when we don't want to develop some type of application, we usually do the same thing, like again and again. Like for example, you might know the keyword CRUD that create, read, update, delete in the web app development. So because of that, like we usually do the kind of similar code again and again. So we believe that we can extract that type of the function, become the built-in function and managed by the OS natively. And then developer can just use this function like natively without need to write any code at all. But consider that the business logic usually complicated. So we might need to have some kind of like custom function. So we want developer to can write their own code, and we make use of the fast engine. So we want it to have the OS upload the invocation for the custom function to the fast system and make it handle the execution. And then we have a data flow function that basically it is workflow of the function, but the difference of data flow function here is that it behave as the function. So that means we can just call it as a function and then use it for the another data flow, because that we can encapsulate them like to look like similar to what we usually do it in the OOP. Like we write a function on top of function, and then we just make a function on top of function again. So here is one example of the class definition. We make it in the YAML format. If you don't know it, it basically it kind of more human friendly of the JSON format. So you will see the more advanced example here in the tutorial. But for now, I just want to highlight something. So we have first we have a state declaration that just say that we're gonna have a video. So this is the video class. And then we have a function definition that say that we're gonna have a one custom class that is the transcoding. So to call the function, we can use the object asset interface. I will go to that later. And then to implement the OaaS, we implemented call it as the Operaga, and we implement it using the Java code, and now it have a 21,000 line of Java code. So we add some more goal on the Operaga. So like first is we want to support both of the structured and unstructured data. For the unstructured data, it basically a large binary file, or we usually call it a blob for the shortened name. And we want to avoid it tightly coupled between the execution and storage module. So that means we don't want the function code to highly depend on the database. So that means we want, if the user want to change the database, the function code should not be affected by it. And then we want to have it have a development freedom. So we want it to be highly compatible with the tool and framework that developer want to use. And we want to minimize the overhead of it. So we can do it like quite simply because of we can make use of the cost domain optimization. And then we want to make it become a fault tolerant against less collision and data consistency across the multiple data store. So as the architecture of the Operaga, we have a few components here. And I want to highlight on the green box that is a Operaga implementation. So first we have a package manager that basically accept the class runtime and managing the definition. Then it will forward to the class runtime manager that will handle get the class runtime definition and make it become the class runtime. So for the class runtime, now it become more interesting. So as we know that we usually not have a one size fit all. Like for example, that with stateful function as service, we might have like multiple pattern to decide the state. So here, for example, like we have an actor model that we just bundle the function and state together. Then when we want to use it, we just routing based on the ingest to the where the actor were. So, and then we have a data store abstraction that we just provide a state API that can be accessed by the persistent storage directly. And lastly, we have a pure function that it kind of based on the pure function that you might know of, that we want to have a function that completely become a stateless. By that mean we want to have a standalone task that bundle the request and state together, and we send it to the function, and then it just get it back by modifying the state. So in this way, we can see that the function is still completely stateless. So OaaS, we trying to use two of these pattern, and as we know see now, there are like a lot of types, and yeah, usually no one size fit all against the application. So we want to have a platform that try to figure it out what is the best match for the user requirement. So in this case, we the OS is not just for the application developer, it's also for the platform provider or like cloud provider. So as the cloud provider, they can make a bunch of the class runtime template. So the class runtime template is basically the template that kind of specify like how the class runtime should look like. And then the OS system will somehow matching up between the class definition and the template and create as the one. So we have a one system that we make use of to make it satisfy on like most of the requirement now, but we can add more later. So we have a one that we call as an invoker. In the invoker, we have a distributed hash table that hold the data because that it can when the request come, we use some kind of a hashing technique to routing the request into the where is the data store in the invoker and meet the data locality on the caching level. So, and as I say that we want to make the function somehow like stateless, that we use a pure function, but not totally. So we to invoke offload the function as for the custom function, we want we will bundle the request and the state as the standalone tab and send to the function container, and then the function container will just handle it and then give back the completion data that is the modified of the state value. And what happens if this process fail? Because now we can see that we have a two type of data, structured and unstructured data. So what we do, we trying to get the copy of the data that if the completion fail, it will eliminate the copy of the data because we have a pointer that point to the new function if the data not come to the invoker. So that means now invoker know that the request failed and the data that updated by the function should not be accepted. So now when the request come again, it just go back to the first data. So we have a few experience set up for this platform. So we have a baseline that is first we have a Knative. So Knative is a file system that is open source and can be installed in the Kubernetes like by a self-hosting. And we use it in the Upalaga. So that's why we want to have a same execution path by using the Knative. And now we have a separate type of Knative. We have a Knative that minimum configuration and Knative with the con that have a concurrency high hinting. And then we have a Knative that have some algorithm to try to figure out what is the target throughput. So we have a three type of workload. So we want to have a chatty that is a JSON randomization. We have a data intensity, and then we have a image resizer. And we have a compute intensive by using the video transcoding. So first, as I say that we want to unlock the code domain optimization. So first we want to show that what is the potential of the optimization that we are talking about. First, we show that in terms of latency. So in the optimization that we can have first is about the data locality, and then is the warm or the so in the servlet, we usually have the problem of something that we call as a warm start because we can scale down the resource to zero. So that means when the request comes, it need to initiate the resource on the fly. That usually take much longer than if we have a resource like ready to be handled the request. So that's why we usually have some problem that we usually call as a cold start. But we can eliminate that problem if we know the exact requirement for the application. So that means if we know the locality between data and the function, we can make them stay on the same host to achieve the local level of the data localization. And with the local, we can reduce the latency by 1.5 times in the chatty application or like 4 times in the data intensive application. And then we go beyond by making the resource become a warm, like eliminate the whole start problem entirely. Now we can reduce the latency by 1.7 for the compute intensive, or even like 46 for the chatty application. And then we want to show that we can provide the throughput guarantee if we know the requirement for the application. So in the Knative or like fast system, we typically rely on the auto scaling. So that means it kind of somehow a base effort. So if the request come, it just do what they can to meet the requirement by spin up the new resource on the fly. But that not always be the case. So as we see that when we have like really high throughput, like in here we can see that there are like 20K requests per second. Like when it go too high, the performance just drop because it just cutting the time out because it don't have enough time to spin up that such high request. So and for the efficiency, as I mentioned that Operaga can make use of the data locality based on the knowledge in the where is the data are and where the function should be. So it can perform much better than the Knative, like and any type of Knative. So and here with the same amount of throughput, the Knative can provide a much higher throughput than the Knative in any application. So now we want to talk about how the application development in Upaka look like. So, and as in the figure, we see that it's really long, like developer just do the class definition and make it become a runtime, and then like we have a user to using it. And now you see that you know that the feedback loop in the development application usually becomes something that really important. Like if you can develop like coding like in maybe like 1 minute, and then we like reload the application and then get the feedback like in a few seconds, that is something that you are really happy about because you can just try an error like as many times as you want and don't get the frustrated, but you need to waiting for such a long time. So, and here we see that in this figure, it's quite long. And normally like deploying the new system, like deploy new application usually take like 10 minutes, 10 seconds at least. So we know that this just will become a bad development experience. So what we can do about that? So yeah, we have a tool that we have called as a OCRI, Operaga Command Line Interface. So first thing is about used to interact with the Operaga API, of course, but it can do more than that. We call it as the dev mode. So it can emulating the class runtime in your machine. Like you don't need to have a cloud, or you don't need to use any like cluster, and you don't need to package the application. So that means you can get the feedback loop in really short time. So to emulate the class runtime that we are talking about, it have a two mode. first is like a one shot invocation. So that means we have a CLI command and we run it and it just uploading the data function as something and it just get it back in the first just one command. Then it have another option that called run as a server. So that means we can just somehow make it run the same way as the class runtime. Why we need it? Because we want to have like external tool that like for example like you might want like developing the web UI and when you want to use the API from the Upalaka to invoke some function and get it back. So and if you have only like one shot invocation by command line, so of course the web UI cannot handle call the command line application, of course. And because of that, so we want to have some kind of like application server that run on like HTTP protocol that web API can just call it directly. So and now another thing that we concern about is that the visibility on the state. So normally we need to have some kind of like database that we need to store the data. But having a database is good, and but it adds some kind of the complexity on the test environment. So now we want to make it a little bit more simplified by just store in the local file at the plain JSON. So that means if you want to know exactly the problem that you are facing right now, you can just open the file and see what is the data right now, or you can just even editing it because it's a plain JSON. And next is multi-cluster management. So you can imagine that if you working on the cloud, you might have a multiple environment, like for example, like testing environment and like production environment. So you think that like you might need to switch between like production and like cloud, like by simply like doing a few action. So we all clients support this kind of requirement. So by using just one command, it can switch between different environment. So okay, I talking about a one-shot invocation, and it might not be visible to you like how it actually works. So let me show you how it should look like, and I will show you the real thing like later. But now see the figure first. So here we writing the code and we run it at the server. So and then now we have a O client with the class definition. It's kind of similar to when we want to deploy it. But now we use the OAuth to emulate the class runtime, and it just uploading the task to the server. So that means you can use any server that you want that accept HTTP request, and that based on the of course based on the Operaga format, of course, but you don't have a limitation of what type of your library that you can use anymore, and you can when you want to test it, you can just run single OAuth command and get the result back. And then when the upstate is updated, it's just writing in the local file. Okay, what about the run as a server mode? How it look like? So it kind of same as before, but when it simulate the class runtime, it run at the server. So now you can use the auto system or like web UI to accessing it. So here we have a tutorial on the GitHub. You can check it out or by using QR code or searching on it. So now I want to set up the my screen. Let me duplicating it. Great. So I think if you want to check on the code, you can just searching with the HPCClab and OaaS tutorial. It might be faster than just using a QR code, I guess. And here we have some prerequisites. If you want to follow them, like make sure that you have all of them. Now, do you have any question? Okay, so then I will continue. So first of all, now I have a OCLI install, but I want to show how to exactly how to install it. So if you click on the link, you will see that there are a bunch of ways to installing it. So the easiest way is go to the release page and just downloading the OCLI by click on your uh, operating system and downloading it. But the thing is, if you are using Mac OS with the Intel processor, uh, it might be old, but if you're using it, you cannot use this binary. So because this binary built by using a GitHub action, and it don't have a Mac with the Intel support for free. So we just using the Mac with the uh, ARM-based chip that like M1, M2, something like that. So, but uh, we still have a second option that you can install it using a JBank. So JBank is some kind of the tool that for the Java application can be used to run the command line based application. So you can just run this few line of code and it just work. But I can say that I uh, pretty much recommend to downloading the binary on it because it compile using the GAR-VM and its performance is much better than the using a JBank that run on the JVM mode. Okay. I will have a quick water break and I will continue with it. Huh? What are you doing? Is there any share in this workshop or is just ending? Oh, share. Yeah, who is like managing, coordinating the presentations or no one? I don't know. I just come in. It's a I share. I give me the manager. Yeah, exactly. I was the guy that. Okay, I see. Okay. I don't know much about it, how the content works, so I let's come that. Yeah. More. I just asked for curiosity. Thank you. Thank you for coming. Okay. Um, okay, still work. So So I will continue now, I guess. So here, in this tutorial on the GitHub, we can see that there are bunch of steps here. So let me kind of summarize what is the step that we want to cover. So first, we have a basic OCRI operation that is just a bunch of standard command line that we can using OCRI. And then I will show like how to add the custom function to the class definition. Then I will show how to implement the custom function itself. And then I will show like how the data flow work. And then lastly, I will show the cluster deployment. So in the first part, I want to kind of clone this project, but in this case, I already cloning it, so I don't need to do that. And I already have a OCRI installed. So in OCRI, it have the helping page. So if you don't know the command that you are searching for, you can just using a -h. Then it will show a list of commands. And now we want to use on the dev mode. So you can use a dev followed by H to see like what is the command that provided by dev mode. And here, first, let's create some kind of demo application. So basically, now we want to create the empty class that completely have nothing. So we can use a dep command and run a PA to it stand for the package and apply to apply the current package. So here we see that it update. So let's try to create some object. So basically you can use command OC that call object create. That and you can try it by using the demo. And we can use a command that's S option to make it set to your local file. And you can put some data using a -h. So let maybe put some hello world here. So and you can see that there are data add to here. So the good thing that I have mentioned that is in OCRI, it save the data into the local file. So you can check on it and you can see that we have a class name and followed by the ND or new line delimit JSON format. So you can try to open it. In this case, I can try run Notepad++. Maybe just cat here. And here you can see that each line it have a object data, and we can just modify it if we want. The next step is what if we want to add the function to this application. So we can just open the package file, and now we know that we can just copy on it. Let me remove this part real quick. So now we just reapply again, and Now we can access to the update function. So in the update function, we can just put the data and make it update like here. But you can see that our old data is lost, like for example, like hello is lost thing. So we might want to modify something to make it merging between them. So what I showing is not just the option for the this update function, but it also show that we can modify the package definition the option or the configuration for the function by using the override and put the list of the parameter here. So in this case, I just pass it here and do the applying package again. And here we can let me create the object again. Then redo the update. And here now we can see that the old data and the update data that pass to the update function is merged. So because of this, we can continue with the next step. So now I want to show you how to manage the unstructured data or the file-based data that we usually not want to put it on the database. We usually put it on a certain type of data storage. For example, here we usually use the object storage that now we want to use, we want to add this option to here. And so because OaaS it not manage the unstructured data or the blob file like natively, so that means we need to have a object storage like running in the background. So to simplify the installation process, we can just use the Docker command here. So it should be, oh, okay. So I forget to turn on the Podman. Oh, basically it's another type of a Docker runtime, but can turn it on now and should be able to use it. Here it's running, and we can try to check on it on the web server by using the local host port 9001, and the password is, I think it's not necessary to show it now. So now we can use the object storage. So we can try to upload the file. So we can just run in this command. And it should be done. Oh, I forget to reapply the function. And here. And because we concerned about the performance, so we to send the file into the object storage, we don't want to use some kind of like proxy to become the kind of add the component and make it become the bottleneck or something. So in this command, it give us the PSI URL that based on the S3 protocol. It's the same as a S3 from Amazon, but because of a protocol itself is a standard, so that mean some open source object storage such as the MinIO, they can just use it. So even though it shows the PSI URL here, but when you running this command, it already load the image into object storage. So now you can try to check if you can load the image back. Okay, now you can see that there are image loading back here. So the image that I am using now is the state of liberty that quite big. It's like 22 megabyte per image. So let's try to add the custom function to resize the image. So the first I want to show like how to add the custom function, not how to implement it by ourselves. So let's try to run the function behind the scene. And now you can just using the Docker command again. Okay, so it's running. And we want to add the custom function. So in here, we have the resize function. Actually, I can just copy all of it. See here. So now we should be good to go, and we want to reapply the packet again to make it reflect. Okay, I think I copied it wrong. Yeah, it should be the name. So sorry for my mistake. Learning it. So now we can try to resizing the image that we just uploading it. So we can run the resize function and provide some argument. Like for now, let's try to reduce the size of the image by half of the width and height. Okay, so I rename the class so it's not going to work by using the same name. So I need to make it become a image. And then run it here and it works. So let me download it again. So here we're using a command def of image. So if you cannot remember the command, you can just always using a dash s. And now let's check what is the size of the image. Oh, I think I forget to run. Here, so the image not completely getting overridden. So that I need to removing it and create a new one. So and now you can see that the size completely reducing by a lot because it's two-dimensional image. So and let's go to the next step. Now we want to implementing the custom function. So to implementing it, we want to clone the template and trying to running it. And here you can see that it is a basic Python application. We have a main.py that is for running this application. And we have a Docker file for building the image container. And we have a package, so we don't need it. So we can just removing it. And now you can see that the IDE not quite config with this application. So let me installing it properly. So first we need to create a virtual environment. So and we need to run the virtual environment. Let's try to add the local interpreter here. Now we want to add the new Python runtime that created by the virtual environment. Oh, look like not quite what we want. Anyway, now we can set up the dependency. So we want to use the one library that used for the remove the background. So we can use remove pg command, and then we run pip install to install every packet that we need. So in the next step, we want to implement the logic. So let me copy it, and I will go to step by step, like how to implementing it. So I decide to just copy and paste here. We wait for a few times to installing a package. So now the dependency is installed, and we can check on the code itself. So here we created new handler that is a remove background handler. And first, we want to download the image that's stored in the object storage. So we can just using this command by calling the context.load main file, and we use the key that is the image, and then we save it as the binary of the image. So then we using the remove command that based on the remove background. So then we can just upload the main data back to the object storage. And we want to change the port to make it not conflict with the runtime that we already running. So then let's try to update the function. Now we can reapplying the package. Let's try to remove the background. So command that we are looking for. here we have a new function that called as a EG remover. Can call EG remove. And because we didn't start the application yet, so we need to start it now. Not quite really start yet. Yes, my editor is kind of bugged for some reason. Me trying to run it. Might take a few seconds to start. And here it start now. So we can try to run the background removal and see it complete. So we can try to load the object back, remove the output. And let's check on this image, what it look like. Yeah. So So now the background should be removed. Here, the background is removed. So, and now I can show you the so let me use to make it quick, so we can just using the another project that I prepare for, that is a final version that compete with the all editing of the data flow. So let's try a part package now. So have a data flow. So the next step that we want to show for the basic data flow is that we introduce a new concept that called as a macro function. So in the macro function, we can describe the multiple steps of the data invocation and make it become a function. So for example, here we create a transform that the first running the recite function, and then it will run the background remove the background size. And here let's try to create a new object again. Okay, let me running it from the beginning. And we can now try running the invocation of the transform function. Okay, I think I used it wrong. Okay, so what I have to do it wrong. Oh, I now realize that I forget to put the argument, so that's why it's not working. But here, so now I run the transform by taking a few minutes, and we can see that we have giving a two output on macro ID. First is output 1 and output 2, and if we want to check on the data, we can just using the OF command again. So
I work for the hotel.
okay.
But I found it interesting because I do data asset management, so hearing your thing, I was like, okay, that's interesting. I'm working, but I would love to know a little bit about, like, briefly describe to me Object as a Service.
Yeah, so I'm not sure how much you know about the cloud computing. So now the cloud, they try to make it kind of become easier for the developer to make an application. So in the latest kind of design or like the state of the art, we have something called the function as a service. So function as a service is kind of similar to that we like how the developer coding. So we code it as a function. So have you do the coding before?
No.
So when we do the coding, we usually do as the entire application. So entire application is mean that you like in the one program, it do everything, like it handle your user request, it do everything. But the function as a they want to change it become like you just drop the function. So function is like you want to do something, you just do that part, and you not need to cover the entire logic. Because the idea is that they want to make your application like separate them, like become a really small one, and then they can do auto scaling. So that means like each function, it on its own, it just do the just reserve the resource and it needs, like compared to the entire application. And the OS that project that I and our lab kind of thinking of that it we want to address the problem of the fast, because the idea of fast is come from the kind of umbrella term like as a serverless, but we not yet get the concept of the serverless yet. So like when you hear the name serverless, you can think that you don't have a server. Like some people just think that yeah, the serverless, you don't need a server, or like you don't have a server. Yeah, that's quite true. So the thing is that
Not as
you you don't it look they want to make an abstraction that you work with like you don't need a server to manage.
Yeah.
But in the fast, it not cover everything. So that's why we think it not completely serverless. So that's why we need to complementing it to make it more complete by using a new concept called object as service. So there are kind of a lot of detail.
Yeah, it's a lot of
Like,
details. But I wanted to see if you can kind of give me a basic, because came in a little bit on it, and I had to leave. And I got a call and I had to leave. And I was like, let me just ask you and see what it is. It's like a website or some pamphlets I could kind of go and look more about it?
Oh yeah. So first of all, this concept is already public at the paper. But for this tutorial, for this tutorial, I have a complete tutorial that like I make a document. That's why I guess people just see that I make list everything, so they don't need to be here, I guess. But yeah. So if you want to check on, you can just go to the GitHub. So I'm not sure if you know the GitHub, but GitHub is the biggest source code repository. And then you can just go to the HPCClab that yeah. So and HPCClab like stand for like high performance cloud computing. That is a lab that I am a member of. And then we have a OS tutorial here that you can just search on the link search here, or just kind of putting the entire URL here. And you can see that they have a entire description on like how to run the thing, or how to add the thing to make it like step by the step. And if you are losing, because this one is designed for that you to do the step by step. But if you lost, you can just check on the branch. If you know about the Git, it just switch the branch and it have the complete version of the project. And then you can check on like what you are doing, what are you doing wrong, and then comparing it.
Are you're just here for today?
Yes.
You're not. This is the only class. You have your class tomorrow too?
I think that for the workshop, it's just for today. So I just I mean I already registered for the workshop. So that
you just did 9 to 12.
yeah. So because now it's like recording. I mean my advisor asked me to recording it, so I just want to make it done, and even though then yeah.
But I appreciate it. I'm definitely gonna check back in. Definitely interested the concept, but thank you again for giving me that information. I'll stop by.
Yeah. I mean I appreciate you that you come to check. Yeah. So in the last part, we have a cluster deployment that it requires you to have a cluster to tie this step. But because it requires a lot of time, you can check on this guide to how to install the cluster on your own. And I will show you like how it works. So first of all, you need to create the more option that is a creative like container image of it. So because this tutorial is the function on this tutorial is already covered by the official source code, so you can just using the source code that automatically built by the GitHub action, and then now you can just packaging it. And you can see that you don't need to put the dep command because of it don't need to use the dep mode anymore. We want to deploy on the real cluster and see now how it works. So let's try it. Object package apply, then followed by the package name. So now if you have some kind of the monitoring tool for the Kubernetes system, you can using it to check on like what it happened behind the scene. So you can see now there are a few containers that spawn in the Kubernetes cluster. Here is an invoker and a bunch of a function. So now you can try to create the object. This time we don't need to use the dep option anymore, and it will take some time because it need to upload the big size of image to the internet. So because the internet here is not the quickest, and I want to use the image size to show how to reducing the size. So it might take some few seconds. So now we can try to run the script. And as you can see, it's found a lot of container. Because of the split function of background removal, it requires a lot of CPU computing because it's in ML-based application that it require a lot of CPU or GPU. But right now the Intel cluster have only CPU. So in each container, it need to take a lot of resource. So that's why when we call split function, it fall into the three function, and each of them just landing behind the scene. So, and here we are, that is complete. As you can see that with the OS, you can still gain benefit of the serverless like auto scaling system, but we can still use the state management. And you can see that when you develop the application, you don't need to handle the state management almost at all. You still need to fetch the data, but everything is handled behind the scene. Okay, thank you for this presentation. And it will be done now. Oh, it's too late now.